13th session of Nepal, 11th Nepal Geological Congress. It is a technical session, mineralogy, petrology, geochemistry, geochronology, and I would like to request Professor Michael Korwitsky, the chairperson of this session, and co-chairperson Dr. Motilal Rizal, and reporter Muranidhi Pokhran. Now I would like to request Professor Michael to present.
My name is Michael Korwitsky. I'm from Poland. Not so far from Asia, but quite a similar alpine structure. So we have to start. Ananta is ready, as I see perfectly. Okay. So Ananta is inviting us for sauna, I think, yeah, with hot spring water. So please, the floor is yours.
Geology of hot spring in Nepal, a short brief review of the works, previous works. Actually, I also involved in hot spring surveying and sampling since 1993, and most of the data I am now talking about the distribution of hot springs with respect to physiography of Nepal Himalaya, geology of Nepal Himalaya, and then finally I will correlate with the hot spring site and the broad geolithology of the area. Finally, I will come to the conclusion. First, I wish to explain about the distribution of these points are hot spring location in Nepal. That these hot springs are widely distributed in Nepal, and there are not relatively hot springs are more in density to the western Nepal than in the eastern Nepal. Nepal from the south start plain area we call as Tarai Plain, and we also get reported hot spring is reported from Tarai Plain also, here also, and then Siwalik goes up to 1,800 meter, and there are few hot springs in the Siwalik footing mountains, that is a very young mountain, and then immediately to the north of the Siwalik there is a prominent mountain range that we call Mahabharat Range, we call as Midlands, and then to the north, to the northern extremes, we see Greater Himalaya. In between Greater Himalaya and Midland, there is a transition zone that we call as Third Himalaya, and then a lot of hot springs are reported from the Third Himalaya also, and then in the Higher Himalaya, there are some hot springs. Now we look at the hot spring distribution with respect to south flowing Himalayan rivers. Then there are some hot springs, Nape and Klippe area in the southern part, western part of the Himalaya, and then there are several hot springs in the higher Himalayan zone, and few hot springs are reported from Tethys sedimentary sequence and gravel deposits. These hot springs actually geologically situated close to the thrust, map and window, and these hot springs we see mostly in the riverbank area, river channel area, and also on the slope, mountain slope. I just wish to show you the distribution of hot spring in the eastern part of the Nepal. Politically, this region is divided as Kosi Pradesh, which is more or less equivalent to the eastern region of Nepal, and there are a few hot springs in the higher Himalayan rocks that is composed of gneiss, migmatite, quartzite, marble, and granite. And then some hot springs are located in the window, and in the window they are autochthonous rocks composed of phyllite, quartzite, and meta-sandstone, again gneisses and amphibolites. These reported from the window area. Likewise, next, in the Baghmati region, there are also hot springs in the higher Himalaya, and also reported from the Kathmandu Nepal structure, and to the south there is one from the Symbolic range, and there are several hot springs located within the allochthonous area. So there are always it is quite complicated to correlate rock types formation wise from east to west, because there are several formation names as explained yesterday by Professor Megraj Dital. Same formation, same type of rock is named as different formation. Quartzite, gneiss, marble, quartzite, then shale, slate is calcareous area deposits, and Symbolic is sedimentary rocks. Next, and these hot springs are actually, if we see, this is the structural control on the distribution of hot springs. We see here in the window area, and there is hot springs in midland rocks, and some springs above the density, Himalayan rocks, and in the window, and then also from the Symbolics. So there is a anticlinorium structure and a synclinorium structure. Then the foothill mountain range. So structurally we see high-grade metamorphic rock transported high-grade metamorphic rock zone. There are hot springs, and also from window area and in the shear zone. To the north, in the northern anticlinorium area, and this is allochthonous rocks and carbonate rocks, as well as there is a few basic metamorphosed basic rocks, higher Himalayan crystalline rocks, gneiss, migmatite, and quartzite marbles. And to the south, there is again metamorphosed siliciclastic rocks from allochthonous area, and there is metamorphosed granitic gneisses, again gneisses, and from the Symbolic area, Holland, Pink Holland, Paleoholland basin deposit. Several hot springs in midland as well as in higher Himalayan crystallines, and then so these deposit we see here, these few hot springs emerged from the graben deposit, and then from the Tethys sedimentary series, there are also some hot springs, and also one spring is reported from leucogranite area, Likewise, other hot spring from higher Himalaya, there are always large number of hot springs, and then below the higher Himalaya, from the meta-sedimentary siliciclastic and carbonate rocks, there are several hot springs, and also from the carbonaceous shale and carbonate rocks. Next slide. So in the Karnali province also similarly there are hot springs reported from the higher Himalaya and the cliff area, and also from the southern area in the secondary zone. Okay, so if we see the geochemistry of the hot spring, then there are dispersal of elements, potassium, silicate ions, sodium, potassium, magnesium, and calcium ions. So if we take stable isotopes, deuterium and oxygen, and this is the world meteoric water line, and lot of hot springs lies in close to the world meteoric water line. So it means there is a circulation of water from the surface and penetrate to the deeper part and emerge from the fracture area. So this reflects circulation of meteoric water, but at least to get temperature around 70-80 degrees centigrade, we need a good relief between the water penetration area, surface water penetration area, and the spring spring located at low altitude, low elevation area. The relief must be at least, there should be 4 kilometer relief. If we consider, for example, 18 degrees centigrade per kilometer of geothermal gradient, so that is possible for the case of this kind of hot spring circulation. But we see there are several hot springs in the Nape and Cliff area, and petrographic analysis of the area. Thank you.
So that we have relatively free time because the third lecture was cancelled, and that's why we have time for questions, please. Any questions?
Very good data on the hot springs of Nepal. Thank you, Ananda sir, for this very valuable research and presentation to us. My small query, because in Nepal there are several hot springs, almost in every tectonic units of Nepal Himalaya. So, what did you observe? The more concentration and more temperature of these water bodies in HFT zone or MBT zone or MCT zone, where is more clustering of those in terms of distribution and in terms of temperature?
In terms of temperature, when we go to the northern part, close to the MCT area, we get a significant number of hot springs, and also temperature is also higher. And when we come to the southern part, the hot springs are warmer than the normal body temperature.
Present my colleagues here. The co-chairman is Dr. Moti Lal Rijal and Guna Nati Pokrel. If you like, Ananta, please. So I have short one, okay? What kind of temperature you have? The highest temperature, for example, in which part occur and relatively to the another amount of temperature, okay? In which part you have the highest level?
The highest level is reported from the western part of Nepal.
Other audience they don't have. So how we can recognize hot spring in comparison to the normal temperature should be in comparison to normal spring temperature?
Yeah, okay. Yeah, normal, I already, the water above normal body temperature, 37 degrees centigrade, right? So these people, they called as a hot, tatopani or hot spring. So normally there are sometime in the southern part of the Nepal, there are some called as hot spring, but their temperature is really low, and that is warmer than the atmospheric temperature. That is also there is this kind of hot spring are also called in Nepal as tatopani or hot spring, particularly in the southern part of Nepal.
Okay, thank you. So just one thing is because there is also seasonal dependency. It's opposite to a normal spring temperature is just opposite, like in warmer season, yeah, it's colder, or in colder season it's a bit warmer. But what we can say in the seasonal dependency? What is spring? Is the temperature stay the same all over the year, or they also differ slightly some degrees?
I did not check this. I have to check.
Okay, thank you, sir.
Okay, you can continue during the break. Okay, so it's the last chance. We'll have a short question. The last one, please. Okay, please. On the back. Sunil.
My knowledge or our studies is that the almost hottest spring in Nepal are located around thrust zone, near the thrust or around the thrust zone. Is it almost correct in your observation that all the springs are located around the thrust zone or other location as well? To be clarified for me. And if so, then all the thrust zone are around the thrust zone. Then all the thrusts are active now, or any other phenomena occurring those hot spring flow? Thank you.
Yeah, there are certain hot springs close to the thrust zone, thrust area, right? So, and otherwise there are hot springs above the thrust and far below the thrust also. There are, and these thrust active thrust fault within the active faults I did not check, but mostly the hot springs are closer to the thrust zones in the MCT area, and also there are some hot springs close to the STDS area. Okay, so MCT and STDS nowadays it is we did not get any report activity of the MCT and STDS area. Okay, so otherwise in the main Himalayan frontal thrust, it is always active, and above the main Himalayan thrust there are also some hot springs in the sea volutes.
So then what will be the real sources for
Sorry?
what may be the sources for those hot spring?
I already talked to you about the sources from the geochemistry, stable isotope analysis. These are meteoric water and hot spring waters are correlated. Okay, so these are both value lies in the meteoric water line.
In a number of springs,
Open your.
we have seen a number of other springs which are not the hot springs, very close to those where the hot springs are situated. For example, when we go to Tatopani area, in the vicinity of the area where the hot springs are located, we can see numerous other springs which are not hot enough. They are the normal springs. So how do you differentiate between those two? For example, as I have already mentioned, in a very close vicinity, though they are very close either to the MCT or while we take the thermal gradient, it's similar. So how do you relate those two things?
It is normal spring. I already there is a publication by Frédéric Perrier, and he explained water percolating from the high elevation area must be around 5,000, 6,000 meter, and that penetrate deep down and come out from the around 1,500 or 1,000 meter elevation. So there is if we consider geothermal gradient, that is enough to get that range of temperature that measured in the field, in the outlet of the hot spring. So in other cases, just for the case of groundwater, that is a shallow circulation of monsoon water, that's why that is not so much temperature.
Okay, thanks a lot. So you have to know, and that's why we try to be flexible, okay, by time. Okay, so thanks again. So the next speaker is ready, I think. Okay, Ashok Dakal with co-authors about some mineralization in Lesser Himalaya. Please. You have 15 minutes and 5 for discussion. Okay.
It's me, Ashok Dakal. I'm very glad to stand here and thank the organizer too. The presentations of my research is geological study of copper mineralizations in Bhutan district, Western Nepal, Lesser Himalaya. Here is the presentation outlines of my research. And Nepal Himalaya is the very potential area for mineral resources, and we are in the preliminary stage of mineral explorations. The Bhutan district can be the potential site for the mineral resources, especially for the metallic minerals like copper and iron in association to the gold too. And the research focus in establishment of the geological relations to the potential mineral deposits. The first and most important stage of mineral prospecting is preparation of the good geological map, systematic sample collections and their analysis. This is the study area which lies in the northeast part of the Bhutan districts, and this map shows the political boundary of the study area. And this was the study area in the geology of Nepal, which lies in the Lesser Himalayan crystalline rocks. Various previous geoscientists worked in the study area where Fuchs and Frank 1970 and Sharma et al. 1984 established the stratigraphy of the area and categorized the rock as the Chaujari formations, Thawang formations and Jajala formations. Department of Mine and Geology 2017 reported the localization of the copper mineralization throughout the Nepal Himalaya. And Italy 1929, Stradrum 1941 and Batsman 1979 gave the method of formation of copper mineralizations, and they told that the mineralization is due to contact metamorphism, replacement and hydrothermal. Some motivations has came to carry out this research, and in the study area, the presence of copper mineralizations is noted, but the significant research gap exists due to the lack of detailed geological mapping for mineral perspective. So additionally, the genesis of copper mineralization and its mineralization characteristics in terms of textures, grade, distributions has not been thoroughly investigated. So the primary objective of my research is to observe the stratigraphic relationship to the potential mineral deposit, to study the whole body morphology and grade value, and the last one is identify the genesis of copper mineralizations in the regions. To fulfill these objectives, this is the methodology flowchart, and I did the three major steps, that is desk study, field studies, which carry out geological mapping, sample collections, and lab study, that is preparation of thin section, poly section, the XRF and AS studies, and to collaborate all this data, the result and conclusions has occurred. This is the geological map I prepared in the field and study of the rocks in the field, and similarly extraction of the sample from the old copper mines, leveling of the sample for test, and I prepared poly sections and thin sections. Now I go to the result sections, and this is the stratigraphic columnar sections of the study area, which comprises the Geological formations, Baglivan granite and Thawang formations. The Geological formations consist of galactiferous schist and meta-sandstone, whereas the Baglivan granite consists granite which has discordant relationship with the host rocks, and the Thawang formation consists of impure crystalline marble. And this is the geological map I prepared, where the yellow-blue color shows the Thawang formations and grey color shows the Geological formation. Baglivan granite lies within the Geological formations. This is the Baglivan copper prospect, and you can see the three old audit which has prepared by the ancient miners in that area, and this is very favorable for copper minerals. And according to the local peoples, before 18 to 19 years ago, the ancient miners used to extract copper from this area. And this is very small, but inside this audit, there are very large, huge audit has prepared. You can see the very clear view of the malachite from the Baglivan copper prospect, and you can also see the red rustings, which is the pyrite rustings, that is the iron rustings, and these photographs also shows that the mineralization is copper mineralization is with association of pyrite mineralizations too. In these photographs, you can see the vein of chalcopyrite. This is the hand sample photographs taken from the inside the audit, and this was the mineral vein is present in the host rock. Okay, and here is the small pink thing, that is bornite, which is also present in the inside the ancient audit. So let's move to the geological control of the deposit. The above columnar section, the upper columnar section shows the position of the copper mineralizations in the Baglivan copper prospect, which lies in the Geological formations. This is the granite, and it is hosted in the galactiferous schist and meta-sandstones. And in the photographs, you can see the malachite leachings, and this rock is granite. So this is the major geological control of that copper deposit. This is the clear field photographs of Baglivan granite, and you can see the perfect exposures of granite here. And you can see the hexagonal crystals of opaque minerals in there. Okay, this hexagonal crystal of opaque mineral present in the granite. That shows the presence of minerals in granite. That is, the granite own self associates the copper minerals. Similarly, this is the thin sections of meta-sandstones, which is the host of the copper mineralizations, and this carry out the opaque the host rock meta-sandstones. Similarly, I classify the granite, Baglivan granites. Then I did the police section analysis, which is for the genesis of copper mineral license, and you can see the very clear. Similarly, these photographs also show the unilateral grain of chalcopyrite. You can see there the yellow color chalcopyrite associated with pyrite. The quartz is the present as the gonz mineral observed in the Paglevan copper prospect. And this also the same police sections photographs, and this very high concentrated copper deposit which is present in the highly disseminated chalcopyrite in high concentration zone inside the audit, and this also the same police sections which consist cobellite and borite minerals. To find out the copper concentration percentage, which is very good in sample number 4, that is by AAS analysis. The handheld XRF was carried out to determine the associated minerals in the copper deposit, and I found the iron, titanium, copper, manganese, chromium minerals, which shows that the mineral deposit is magmatic because maximum minerals, metallic minerals, are present in the ore body. The copper zonation map, here the blue zone of in the map is the copper zones, and you can see the ancient ore bodies, several ancient ore bodies, and the yellow point shows that the sample locations, and this is for the gross reserve of the deposit. And I found that the reserve of the deposit is 2.4 million tons. Now move to discussion. The northeast part of the Putan district is characterized by the Chaudhary formation, Thawang formations, and intrusion of the Baglevan granite. That is, Sharma et al. 1984 described the stratigraphy of the Chaudhary formation, which include crystalline rocks such as schist and quartzite. In the study area, granitic intrusion refers to as the Baglevan granite, which is 500 meter thick, and the Thawang formation consists impure marble. Granodiorite of the Baglevan granite embodies copper ore minerals, which is clearly exposed in the metasandstone of the Chaudhary formation. Gross reserve of the Baglevan copper prospect is 2.4 million tons, considering specific gravity 4.8 using the particle section method. After 1981 indicate the mineralization of the copper and tungsten in Bamangam. The mineralization of the copper at Bamangam was reported as green siliceous to feldspelite, which was in contact with the Daldura granite. It is a very important discussion on the copper deposit of the Baglevan copper prospect. According to the Niggli 1929, the iron and coppers are deposited by the hydrothermal process. Due to the exclusive rock-like granite, the Baglevan copper prospect belongs to pyrite and copper associations. You can see in the figure also. And according to the batsmen, the host rock consists opaque minerals in the vacant area, which is the cavity filling by minerals observed in the thin sections of the host rock. In the same way, chalcopyrite is replaced to bone and described that the process is hydrothermal, where the sulfide minerals are deposited in the host rocks and oxide minerals are leached in the surface of the host rocks, which is also clearly seen in the Baglevan copper prospect. Now, I move to the conclusion. The Chaudhary formation is highly favorable for metallic minerals deposit with copper mineralizations observed in the contact zone between Baglevan granite and rock of Chaudhary formation. Copper mineralization is hydrothermal type, contact metamorphosis type, and works in granite and metasandstone. Granodiorite as the source of the copper mineralizations. Features such as chalcopyrite bed, dissemination of chalcopyrite with pyrite, presence of opaque minerals in cavity filling process in the host rock alongside quartz as the gonz mineral indicate that the Baglevan copper mineralization is hydrothermal type with a copper grade of 0.69% with good area extension. The deposit is economic in nature. Thank you.
I have a few queries regarding the association of gold mineralization with pyrite and chalcopyrite. So, did you notice any gold deposits? Though it's hard enough to look directly under the petrographic microscope or the ore microscope to distinguish between the chalcopyrite and the gold, but did you find any type of magnetite deposits associated with chalcopyrite? Because most of the gold, especially in this orogenic setting, is associated with magnetite, and and the chalcopyrite surrounding the magnetite, and if you have any evidence of such photographs or if that type of data or that type of field scenario, you have seen.
According to you, these types of hydrothermal deposit, gold mineralizations is very possible to deposit it, but I did not do any panning methods to estimate the gold. And according to you, the old sample or old body has not any attraction to magnet. So I think this deposit does not did not consist any magnetite, but the deposit is magmatics. So there must be gold, but further investigation is required.
The host rock of this 34 mineralization, is it deformed?
Slightly deformed. Some deformation features D1 and D3 can be seen. Yes, this here too.
So the next one, please. You want?
We can use as a copper mine
Yes.
or two samples. One is 1.57%.
Yes.
Another is almost 1%. Yeah.
Yes.
And how much is the deposit? Is how large deposit is that, so that we can economically harness it?
8.4 million tons from the gross estimations, and I take the sample from background, that is from the outer audit, and I also take the samples from the inside the audit, which has high value of coppers, but outside the audit it has low value, low grade of coppers. So it has 2.4 million tons, which must be economic for mining purpose.
Thank you very much.
Thank you.
Okay, so just what would you recommend to the concerned authority? Is it feasible to mine or is it not feasible to mine?
I confirm that this is very feasible to mines, because it is very good grade of copper mineralization. That is, I think in India or in around the world, many countries started to mine the copper under the 1%. That is below 1%. So it is below above the 1% the copper grade. And another is the quantity of copper mineralization is also very large, because I did not the detailed observation. That this is very the prospecting phase of my research focused on the prospecting phase, but along the granite body, the whole granite body consists of opaque minerals, so that just contact with the granite body, the mineralizations are visible for mining.
So that means you would recommend to localize investigation of the particular sites, right?
Sure, sir.
Okay, thank you.
Thank you, sir.
In the Kathmandu River basin, a study of downstream sediment. Now, Suman, floor is yours. You have 15 minutes for your presentation.
Thank you, sir. Hello, everyone. Along the major rivers of Nepal, and this is the part of my research. I have chosen Kathmandu River basin for this research, and in this research, I am analyzing texture and maturity status along the Kathmandu River basin and its downstream variation. My supervisor is Dr. Raj Kalvata. For the background, the Kathmandu River is a trans-boundary river that originates from the China, from the Matsatungo glacier. It is one of the longest rivers of Nepal, with a length of 530 kilometers, covering an area of around 46,100 kilometers square. The study of sediment, its characteristics in river system provide critical insights into the geological process, shaping landscape over time. The downstream finding of sediments is a widely accepted concept in fluvial sedimentology based on the premises that sediment grain size decreases downstream as a result of longitudinal decrease in stream power. However, the lithology, geology, hydrological condition, and channel geometry also plays major role in the downstream decrease in size of sediments. Therefore, study of sands as a size grade analysis and along the river process changes as they record the physical and chemical processes acting on the sediments during transport. However, there is limited information on how these sediments characteristically vary, specifically in the context of Himalayan river system, particularly in Karnali River. Apart from its significance in geological aspect, it is significant for engineering purpose too. Investigating the textural maturity and downstream variation in the Karnali River will fill this gap and contribute to a more comprehensive understanding of sediment dynamics in mountainous river systems. These are some of the names of the researchers who have done research in different rivers of different continents. This is the study area, map of the study area, showing the geological boundaries and tectonic units of the Karnali River basin. Previous global studies have established robust methodologies and frameworks for textural and maturity analysis. For 1974 have established standardized method for analyzing sand texture and composition. For texture analysis, I have used Power's roundness chart to compare the outliers of quartz and to determine the roundness. For determining the sphericity, I have used Rittenhouse chart. This is the longitudinal profile showing different sampling location and tributary location of the tributaries. The sampling started from the place called Tumkot village, lying at an elevation of 3020 meters, which is in Humla district. It lies in the northwestern section of the study area. About 48 samples along the main channel of the Karnali River were collected, and 11 from the tributaries of the Karnali River system. The upstream and the mid reaches of the Karnali River is covered by high mountains. Sample KR1 to KR43 lies in the upstream and the mid reaches of the Karnali River, while sample number KR43 to KR48 lies in the lowest elevation area. This is the method applied. First, the sample is collected from the location, different banks of the Karnali River, and then it was dried and dry sieved. After the sieving process, the sample were then analyzed through binocular microscope. Different size grades were analyzed, coarse, medium, and fine sediments of sand were analyzed for roundness and sphericity. This figure shows the size grade analysis after sieving. These are the samples obtained from the upstream stretches of the Karnali river system. Here the samples are distributed randomly. This figure, this graph shows the samples collected from the mid reaches of the Karnali river system. Mostly in this graph, the samples, the sediment distribution is towards fine size. This is the size grade analysis from the lower stretches of the Karnali river system, where the size distribution of sediments are towards mostly in the fine size. This is the method applied for statistical analysis of the sediment which was earlier developed by Folk and Ward in 1957 for statistical analysis, inclusive graphic standard deviation, which gives the sorting of the sediments, and inclusive graphic skewness, which gives the sediment different size of sediment skewed. Different color variations are shown for different samples taken along the Karnali River system. The topmost part is from the upstream stretches of the Karnali River system. Here, along the mid stretches of the Karnali River system, poorly settled to moderately well settled, almost moderately well settled. And the skewness, this second graph shows the standard deviation, which is to analyze the sorting of the sediment. In this figure, as we can see, the trend line is decreasing. From this, we can ascertain that as the river flows downstream, the sorting is improving. The third graph shows the skewness of the sediments collected from the Karnali river system. Here, the skewness is increasing, which means the sediment size is decreasing as the river flows downstream. The fourth one is the kurtosis graph against the downstream variation. We saw the kurtosis value, the trend is almost similar, which means there is no drastical variation among the segments. The roundness is angular towards the downstream stretches in the coastal side segment, while in the mid side segment the angularity is slightly towards subangular type, and in the fine side segment of along the Karnali River system, the angularity is towards subangular type. In this table, I have analyzed the maturity status along the downstream of the Karnali River system, and I have found that the sediments along the Karnali River system is mostly somewhat in nature, which is found by analyzing the clay content. If the clay content is over 5% in the sediment, then it can be termed as immature. If the clay content is over 5%, then we have to analyze the sorting of the sediment. While analyzing the sorting of the sediment, if the sorting is over 0.55, we can term it as submature. If the sorting is under 0.5%, then we have to further analyze the roundness to ascertain the maturity of the sediment. The roundness under 3 illustrates that the sediment is mature in nature, while the roundness is, if it is over 3, then it will tell us that the sediments are super mature in nature. Using that method, I have analyzed the segments, percent fines, sorting, and average roundness along the Karnali River system, throughout the Karnali River, and found that the sediments are somewhat mature in nature. Coming to the conclusion, the expected downstream trend are other, such as improving in sorting and shift in skewness from coastal to fine. The study revealed that sands are mostly subangular to angular in shape, and predominantly some mature status of sediments throughout the river course. This suggests that the Karnali River basin sediment dynamics are influenced by ongoing erosional process and sediment inputs from various sources along its path. Thank you.
Main river system of Nepal. Now, floor is open for questions. From your conclusion from this great morphometry and great statistics, what you can summarize for regarding the sources, courses, and pathways of these sediments?
Study, I have found the process is the process of the river is to transfer the sediment from one place to depositional basin, different depositional basin, and during the process the sediment gets aerated and during abrasion the sediment gets different sediments are in different sets. Mostly sediments which are near to the source region, the sediments are angular in shape. As it flows downstream, it gets more roundness and obtains more sphericity. In that way, we can analyze the source.
Affect the river morphology and deposition of the sediment in either side of something like Gerwa or Gerwa side of the Karnataka river or something like that. Do you have any observation?
Actually, my study is not focused on the morphology of the river system, so I cannot tell anything about it. Either it can change or it cannot change the morphology of the river system. I'm mostly focused on the sediment maturity of the sediment along the river system.
Okay, thank you.
My question is regarding the timing of your sample collection. Are those all the samples from recent time or from the river, or are you collecting the sample from the paleo soils or from the left or right bank of the streams, that river systems? Can you get my point or not?
Thank you for the question. All of the samples collected along the river of Kathmandu River is from the recent depositional plant, not from the terrace deposit, which are from the earlier deposit, which are the earlier deposits of the Kathmandu River. Recent deposit, and then they are from the recent depositional plants.
So, next question. Okay, yeah.
For example, when a sediment gets down from the province to the deposition area, then during that time it gets devolved and the maturity it breaks down in the path. So what insights do you have for that?
Another part of the research, as you have told, as the sediment gets reworked, it can change the maturity status, maturity level. Yeah. During the transportation process, as the sediment gets deposited and then retransported, it can be further broken down and can attain angularity, more angularity, which means the sediments are which can deviate us from to determine whether it is derived from the farther source or from the near source. That we can analyze. Therefore, in my study, I am analyzing the sediment mostly quartz mineral. I am analyzing quartz mineral, which is not affected by the reworking process.
Okay, thank you. If we have any question, then the last question. Okay. Thank you all the participants for your active participation. Thank you very much.
Thank you very much, sir. Now I would like to call Professor Dr. Kumar and Bore to present the token of appreciation for our chair, co-chair, and rapporteur.